Hi, welcome to our second video on snow. On this video, we're going to be talking about how snowflakes form. So what makes a snowflake turn into a snowflake, how it's created, and how you get the different shapes of snowflakes, because as most of us probably heard, no two snowflakes are alike. So we'll talk about if that's actually true or not as well, and why or why not that might be true. Now to begin with, let's talk about how snowflakes form. So first of all, snowflakes form really high up in the clouds. They're way up there where the temperatures are a lot cooler. And what you have way up there is you've got the air being pushed up, and with that air comes a lot of different things like little dust particles. So I'm going to draw some little dots on the board here. So this is all inside of the cloud. I hope you can see these little black dots here. And what happens is all the moisture that's in the air, what happens is they find these little specks of dust and dirt that are floating in the air, and they end up attaching themselves to it. And so what you start to get is you start to get water molecules attaching to these pieces of dust or dirt that are up there in the clouds. And as water starts attaching to them, it provides a larger surface for more and more water to condense on the same surface. And what starts happening is up there in the clouds where it's really cool, that moisture starts to freeze. And you start to get the formation of crystal, basically. So you're making these crystallized water up there. Now, snowflakes, when they first start, when they're like this, because of the way that water is formulated, with it being those Mickey Mouse ears that we're all pretty familiar with. Let me draw that really quick. So we usually see water. You've got your oxygen and then your two hydrogen atoms. Now, when water molecules chain together, what typically happens is you get these connections that are formed at these angles. Oops, this one a little bigger. And you start to get a shape. You start to get a hexagon shape there. So I didn't draw my hexagon too great, but you start getting this hexagon shape, and it's from that hexagon shape that the snowflakes start to grow outward into different types of snowflakes. And things like the humidity in the air can change the way that this snowflake and the way that this water molecule forms together. Temperature is also a really big factor. So depending if it's just a few degrees below freezing, or if it's 10 or 15 degrees below freezing, you'll start to get different arrangements of these water molecules to form different types of snowflakes. But really, they're all based on this six-sided shape that you get as the water starts to condense. So for an example, some of the most common snowflake types that you see are ones like prisms. And those are pretty flat looking snowflakes. Oops. But they do have a little 3D dimensionality to them. So if you look at them up close, they look kind of like this. There's kind of a flat hexagon there, and it's got just a little bit of a depth to them. So those ones are really small, and they tend to form somewhere around the 30-degree point or so. Another common one are plates, which look kind of similar to these as well, and those form when it's usually about 28 degrees or so. The most common snowflake that at least we see depicted is what's called the Dendrite Pattern. So that is one where you've got these equal six sides here, and it kind of looks like a little tree where it's branching out, right? This is kind of the traditional snowflake. Now, if you ever see this where it's got more than six little arms to it, it's not actually depicting a snowflake because of the symmetry here. It's always going to be six, or it can even be 12 arms to it, some type of multiple of six to it. So these ones are called Dendrite Snowflakes. And those ones are usually really soft, they're really fluffy, they're usually a larger size than some of the other snowflakes that I've mentioned already. I'm going to show you a great example of one of these that was captured here in Muskegon by Cami Morin. So thank you, Cami, for sharing your photograph with us of a Dendrite snowflake that she found in her yard in January here, so not that long ago. That is pretty common. The most common, though, is dendrites like this that have kind of been crushed on one side or kind of fused together with another snowflake, and you get these kind of irregular shapes and patterns to them. That's the most common because of what happens after a snowflake is formed. So once that snowflake is formed, it's still up there. The wind is blowing it around until it's heavy enough to start dropping downward. And as it's moving around, it's bumping into other snowflakes. And sometimes they might bump and fuse together, it might break off, one of these arms on this snowflake. So you might get a little bit different of a shape to it. Sometimes you get a whole little grouping of them together, 3 or 4 snowflakes that kind of mesh and meld together. And so you'll get some different shapes in your snowflake there. And that's the most common thing that you see if you look at snow up close that's fallen to the ground, is you get these kind of odd shaped flakes where several of them have joined together and kind of mushed together and broken off parts of each other to create these kind of more unique shapes or patterns to them. But if you could break them down back into their individual sections, you might be able to see that sometimes. You're going to see that you have this kind of six-sided symmetry to the original snowflake that was there. Now, I mentioned the whole thought of no two snowflakes being alike. Well, that's pretty true because of the path that each individual snowflake is going to take. So as they're moving around in the clouds there, they're bumping into other things. But some of them are going to bump into more things than others. Some of them are going to move to different parts of the cloud where the temperature is cooler. And so their water might freeze in a different pattern once it gets to that point. Scientists have, however, been able to make identical snowflakes in laboratory settings by controlling the conditions exactly. So by controlling the same amount of moisture, same amount of humidity, exact same temperature, and making it stable through the same point in time, they're able to make duplicate snowflakes. But it's not easy. In nature, you're not going to see it happen because of all the different things that can happen to a snowflake before it actually reaches the ground. So hopefully you enjoyed learning a little bit about how snowflakes are made, and check back, we'll be having another snow video coming up shortly.